Okay, so I have a method for solving chemical equations. Well, not solving them, balancing them, which could be quite beneficial for difficult equations where there's more than two or more than two products or more than two reactants. So I'm going to show it with the complete combustion of hexanol first. So if we were to write out C6H11OH plus O2 going to CO2 plus H2O initially, we there is a formula we can use to solve this, which we're going to use initially just to make sure that when we do my method, we get it correct. So that's the method. The formula is going to tell us how many moles of oxygen we're going to have, and that is X plus Y over 4 minus Z over 2, where X is the amount of carbon we have, Y is the amount of hydrogen we have, and Z is the amount of oxygen we have. So if we were to substitute the values for hexanol into this would be 6 plus 12 over 4, because don't remember, you need to add that up. If you're at GCSE, just remember that. And then that's 1 over 2, and that gets us 8.5. If you're at GCSE, make sure to multiply through by 2 to get to 17. But at A level, you're allowed to leave it as that, I believe. I don't believe you're allowed to leave it as that at GCSE, though. So that tells us we have 8.5 oxygen, 6 of that, 6 of that. And that is now balanced. If you want it to be nicer, just make sure you're checking with your exam boards that you are allowed to use fractions. I do OCR chemistry, so for my exam board, you are allowed to use fractions where it's like 8.5 like this. But I'm unaware if that's the same for other exam boards, so you may need to multiply by 2 to get 2 of that, 17 of that, 12 and 12. So let's do it with the method that I've come up with. Typically, I wouldn't want to use this method on something like this because it's more complicated than doing that, because that takes 2 seconds to plug some numbers into an equation which you will have memorized in your head. Whereas the method I'm doing, it takes a lot of logical thinking and it's quite mathematical, though typically you should get away with this if you've done GCSE maths and you understand basic algebra. So we're going to label everything as A, B, C, and D. And we now need to write all the amount of everything in terms of A, B, C, and D. So let's do this for carbon so you can see what I mean. So there's 6 carbons in the molecule here, and that means we're going to write 6A. There's no carbons in oxygen, so we're just going to say equals, and there's 1 in there, so that means it's going to be 1C, and there's none in there. Let's do this for hydrogen now. And there's going to be, voice crack, there's going to be 12A. There's no hydrogen there, no hydrogen there, and here there's 2D, because there's 2 hydrogens, so that means we're going to write 2D. And let's do this for oxygen now. There's going to be 1A plus 2B gets us to 2C plus D. That equation we formed now for oxygen is the most complicated. So we're going to write C and D, these two in terms of C and D on their own. Then we can substitute this into the oxygen equation and get everything in terms of A and B, which makes it a lot easier to work with. So let's do that. So we already know 6A is that, but it's obviously 2 C's. We don't actually need to rearrange these, I've just realised. So it can be A plus 2B is equal to 2, 6A plus, and then that's 2D, so 6A is equal to D. And if we now write this out neatly, we get 6A is equal to 12A plus 6A. A plus 2B, and that tells us B is equal to 17A, 2B, so B is equal to 8.5A. And that's telling us that the amount of oxygen moles we have is equal to 8.5 more than A, which, if we look at the balanced one up here, we'd know is correct, because here we can see that A would be 1, but it's 8.5 mole. Whereas if we multiply by 2 to have 2 hexanol, we'd have 17 of this. So this tells us it is correct. Because this is a simple combustion question, you wouldn't need to resubstitute back into the original equations. Whereas, where have I put my complicated one? Let's have a look at my notes. Let's do this complicated one, which is what I developed the method from. So we have C6H12O6, which is glucose. This is a exam question from some past paper, I believe. This is an A-level question, not a GCSE question. However, if you're doing this at GCSE, you won't need to know it to this level, but knowing how to do difficult ones will be good for the future, because they can get a little bit complicated at A-level. So, again, let's go through A, B, C, and D. And now we need to write out everything in terms of carbon, hydrogen, and oxygen. So carbon is going to be 6A is equal to 3B plus C. Because there's 6 there. In here, 1, 2, 3. And here there's 1. Let's do that for hydrogen next, which is 12A is equal to 6B plus 2D. We can simplify this down to 6A is equal to 3P plus D. You can kind of see that the stoichiometry for these C and D will be the same if you just rearrange those in your head. And if we did the same for oxygen now, we'd have 6A because there's 6 here. There's 1 oxygen in here, so that's 1B. And here there's 2 oxygen, so that's 2C. And there's 1 oxygen in the water molecule, so that gets us D. The next thing we need to do is look at which one's our most complicated formula, and that would be, again, for oxygen. The rule of thumb is to do oxygen last in most questions when you're balancing equations. So let's rearrange carbon and hydrogen so it's in terms of C and D, which then we can substitute into the oxygen equation. So we get 6A is equal to 3B plus C. We can write this as C is equal to 6A minus 3B. And if we did the same for D, we'd get D is equal to 6A minus 3B. What this is telling us is that the stoichiometry for carbon dioxide and water will be the exact same. So it gives us a little hint. So if you get this far and you wanted a hint, you could use that. But if you have a hint and you've got the hint now and you can see the answer now maybe, then that would allow you to go through with it a lot more easily. But you might not be able to see the answer with this one, so we're going to go through with it fully. The next thing we're going to do is substitute into our oxygen equation, which is 6A is equal to B plus 2 lots of C plus 1D. And if you were to expand this out, you'd get 6A is equal to 18A minus 8B. And if we were to now get A's and B's on either side nice and neatly, we'd get 8B is equal to 12A. Which, if we now divided through by 4, we'd get 2B is equal to 3A. And that tells us B is equal to 3 over 2A. So, that's saying for every one lot of this we have, we're going to have 1.5 times more here. So, if this was, for example, 4, we'd have 6 here. We can now substitute this number back into this here. So we can get C and D in terms of A. So if we write the equation for C/D back out, you get 6a is minus 3 over 2a, and that's 9 over 2a, and that tells us C and D is equal to 3 over 2a. Now, you're going to have to use some initiative here to notice that the getting C and D in terms of A is the exact same as B, so that tells us C is equal to D is equal to B. And once you've done that, you can kind of see the answer from here. But if you were to say let A equals 1, we can form a ratio to say this is A to B to C to D to get 1 to 3 over 2 to 3 over 2 to 3 over 2, and we can now simplify this equation, this ratio, by multiplying through by 2 to get to 2 to 3 to 3 to 3. So that tells us we're going to have 2 glucose to 3 whatever that is to 3 carbon dioxide to 3 water, and we've just done not an overly difficult question, but it's a different way of thinking about it, which might be useful for more difficult questions. Please like and subscribe. Bye.